We can actually look so far out that we can see almost back to 13.8 billion years ago, which is very close to the Big Bang. We now know how our world ends. Our affinity with sci-fi movies and perhaps the Bible would point toward the big, bad apocalypse. But what if we told you that the end of the universe is no different from its inception? The James Webb Telescope has revealed that the universe has stopped expanding. Popular scientist Brian Cox made this prediction years ago. In doing so, he gave us the most realistic starting point to imagine the end of the world. We can look to light that began its journey before there were galaxies, and that's the oldest light in the universe, which is, by the way, one of the pieces of evidence for people who don't believe in the Big Bang. The answer is, well, you can see it. We're heading towards Big Bang 2.0. Join us as we explore why the world has stopped expanding and James Webb's terrifying discovery. If we're certain about anything in our knowledge of the universe and its history, it's the fact that our very epoch of existence is centralized around this event called the Big Bang. Of course, there are alternative theories that recognize the beginning of the universe, such as eternal inflation or an oscillating universe, but we're not getting into the validity of these theories today, mainly because the astronomical community has now readily accepted that our history in this universe starts with the Big Bang. The ideas that succeed the Big Bang are also based on the same common point of the universe's birth. While the Big Bang is a common term in the theoretical knowledge of astronomy and space, we're hardly aware of the nuances and the how of the phenomenon unless you're a nerd who has spent hours watching some excellent visualizations of the Big Bang. To be fair, the phenomenon was more than an explosion, so to speak. Simply put, the Big Bang finds its origin in a single point, a point that was infinitely hot and dense, that inflated to extreme lengths. All of this was when the universe was incredibly young. Believe it or not, at the time of the Big Bang, the universe was only 10 to the power of 34 seconds old. That is 100th of a billionth of a trillionth of a second in age. This is when the universe experienced an incredible burst of expansion, aka the infamous explosion or inflation. During this process, space expanded faster than the speed of light. So yeah, you wouldn't have even blinked when the universe grew 90 times in size almost instantaneously, from subatomic size to golf ball size. 1 second after the inflation, the universe began to cool, and that led to the formation of matter as we know it today. So yeah, as far as the timeline goes, within a second, our universe was full of every particle we've learned about in our chemistry class, willingly or otherwise. Protons, neutrons, electrons, anti-electrons, photons, and neutrinos are the legacy of the Big Bang. Magical, right? Well, figuratively it looks like it, but our understanding of the universe's inception is highly theoretical. We've come a long way since the first moon landing, and since then our technological advancement has grown exponentially. Back when scientists were studying the Big Bang only based on mathematical formulas and scientific models, they wouldn't have imagined that we'd be exploring the possibility of life on Mars. There have been some big breakthroughs in our pursuit to study the universe and explore space, yet even then, our existing technology is pretty limited. You see, we can't recreate the Big Bang or peer back at the event itself. Our biggest piece of evidence comes from the cosmic microwave background, which has allowed scientists to observe the echo of the Big Bang. While this mechanism is groundbreaking in the study of the universe, it's also theoretically limited. The biggest barrier in this particular methodology is the fact that we can't see the gravitational waves or the residual radiation that came from the expansion itself. So while our entire knowledge rests on theoretical tenets, scientific theories have a large room to be disproved as well. Yep, we're pretty sure about the Big Bang as the concept and how it was monumental in creating our universe, but there are some chunks of its aftermath that we've gotten wrong. And as shocking as it is, theories about our universe are largely based on data that is prone to human errors all the time. At the same time, some of our data is also highly conclusive about the Big Bang. Let's just say that at this point in time, it's not easy to disprove the theory altogether. In the last decade or so, our only saving grace to study the Big Bang was the Hubble Space Telescope, and now, of course, all bets are on the excellent precision of the James Webb Space Telescope. Before we got to use these powerful technological instruments, one of the biggest points of contention in astronomical study was the expansion of the universe. If you pick up some science textbooks from the early 90s or so, you'd read about how the universe is widening. In other words, the universe is expanding, and that's one little scientific fact that we've held on to. But the real snafu here is that perhaps we don't understand what the expansion of the universe entails. And more importantly, we've got to ask ourselves if the universe is actually expanding because, spoiler alert, the James Webb Space Telescope is telling us otherwise. Lo and behold, the universe has stopped expanding. And hey, while the world is still intact, you might want to improve your internet experience to be safe and secure because we certainly have. This is why we're happy to reveal our very own secret to secure browsing and accessing deep blocked content to make some hefty, informative videos. Today's video is sponsored by the champion of safe and accessible internet, Atlas VPN. With more than 6 million users worldwide, Atlas is changing the game for everyone. Alright, this service won't be available in space, but Atlas would make your internet experience super secure and quick. Can't watch shows that are locked in your region? Connect Atlas and voila, you're in. You don't have to be an expert in tech or computers to use the service. It works like a charm for anyone and everyone. That too for just $1.83 per month plus 3 months extra. So why choose Atlas? Atlas kills malware attacks, keeps your good searches secure, unlocks content from all over the world, and offers the best deals in the market. You can get all of this for all of your devices via a single subscription. Grab the big deal because now Atlas VPN Premium is just $1.83 per month plus 3 months extra. And with a 30-day money-back guarantee. Protect your privacy and get many benefits of Atlas VPN for a ridiculously low price. You can take this deal by clicking the link in the video description below. Be quick as it's a limited time offer. So while we thank Atlas VPN for sponsoring this video, click the link in the description to avail of the limited time offer. Your internet experience just got a whole lot better. And now, before jumping into the implications of this groundbreaking shift from our universe's theory, let's just talk about our understanding of this perplexing phenomenon in the first place. The most common knowledge associated with the Big Bang characterizes it as an explosion. Well, fiction and popular media have put solid imagery to this process as well. Any piece of media would depict the inception of the universe as some sort of blast that hurled tons of energy and matter, just spreading in every direction. Scientifically speaking, that sort of visualization isn't correct. Despite the widespread use of the explosion analogy, the birth of the universe wasn't exactly a blast. Scientists want us to correct our understanding of the universe. In NASA's own words, the universe did not expand into space as space did not exist before the universe. Instead, it is better to think of the Big Bang as the simultaneous appearance of space everywhere in the universe. Our understanding of the phenomenon also reveals that our universe has lived through a durable cosmic period that was only disrupted by the reionization in space. Before that particular chemical conjecture, our universe was just pitch black. The let there be light moment of the universe only occurred 100 million years after the Big Bang. Yep, that's right. You see, the big explosion only created the basic tenet of all living beings and heavenly bodies in the universe. For 400 million years, the universe was plunged into darkness because, well, it's simple. There were no stars or galaxies. When that was rectified as clumps of gas turned into stars and galaxies, only then did the universe get out of its cosmic dark ages. So here's a little trivia for you guys. When do you think our solar system came into being if the universe was just darkness and eeriness for 400 million years? Well, our solar system was born 9 billion years after the Big Bang. So yeah, sorry sci-fi movies, there's a huge disconnect between the so-called explosion and scientific theory. And of course, this changes everything. The way things are, our universe still exists as a single inception point. It hasn't moved or expanded ever since the Big Bang. What really happens is that space has been stretching along with time, and it carries matter with its trajectory. To put it in clear-cut words, the universe isn't expanding the way we visualize it or even understand it. It is actually the active stretching of space that precedes the expansion of the universe. We know it's a bit complicated to comprehend this, but it's also important to understand the implications of what we're about to tell you. For the purpose of this video, we continue to use the phrase expansion of the universe to signify the active movement of our space, mainly because even scientists are comfortable using the exact framing to describe the recent discovery made by the James Webb Space Telescope. The fact that the universe has stopped expanding is both terrifying and inconsistent with the timeline of our universe. Our understanding was primarily based on the premise that the universe had continued to expand since its creation. The expansion has always been represented by our most prized astronomical possession, the Hubble constant. It basically measured how the distances between the galaxies were changing and widening over time, and that particular measurement was the only piece of evidence that alluded to the expanding universe. So yeah, the Hubble constant was our key to validating and supporting the Big Bang theory. Of course, the expanding universe is also backed by theories that come from general relativity, but you know what? The space age has only just begun, and the technology we now have is in direct opposition to these older theories. That's what brings us to the highly advanced James Webb Telescope, a piece of technology that is changing everything. As it so happens, our limited understanding of the universe is no longer viable because what we once knew doesn't hold up to the scrutiny of the telescope's data. There's a considerable disconnect in the data and the models that were previously thought to be accurate. And this is the main reason why astronomers are afraid. The stakes are quite high here because the Hubble constant has been the cornerstone of cosmology and astronomy for decades, and now we've got nothing to go by. The incongruity here is so big that cosmology now stands at a major crossroad. Our understanding of the universe's expansion could have just been a fluke, and if this assumption is now being disproved, then perhaps the future of cosmology is in shambles. It gets worse because our fear is in tandem with another mysterious space phenomenon, the dark energy. The reason behind the universe's expansion has always been attributed to this hypothetical, invisible energy that permeates all of space and works against the force of gravity. Dark energy is believed to be a powerful energy that pulls the universe outward and thus pushes the galaxies away from each other. It has been understood that dark energy is responsible for accelerating the universe's expansion. The mystery deepens because, now that we've hit a roadblock, cosmologists can't really tell if this theory has any ground. We don't know what to think, but one thing is certain. Dark energy is powerful, but it is perhaps not as strong as we imagined it to be. To put it bluntly, there's no way to know for sure what happens next because we don't know anything about dark energy itself. It was, after all, just a theory put in place to make sense of what we observed, and now the observation has shifted. So here's the most terrifying aspect of this development. The James Webb Telescope might have just revealed that dark energy is growing weaker, or perhaps it doesn't even exist. We don't really know if this inconsistency in our data is anything to go by, but experts are now questioning the theory that space is uniform. If our universe had stopped expanding, it would mean that there's a fault in our understanding of the cosmos. Perhaps the universe is now collapsing in on itself. The discovery is terrifying, and scientists have now called it a cosmic doomsday. Our universe will likely head toward an event that's similar to the Big Bang, but this time it'll be a big crunch. The very fabric of space-time is likely to collapse, and there will be no more stretching in space. Some theorists even argue that the Big Crunch would eventually turn into another Big Bang. But this theory is still being speculated because we don't know anything for sure. At this point, scientists are only speculating about how our universe will eventually die. But the latest data from the James Webb Telescope isn't doing any favors. It's only revealing how everything we once knew might not even be correct. The importance of Webb's findings can be boiled down to one simple fact. If this theory holds, then there will be a cataclysmic disruption of every concept, model, and theory of cosmology. But the most glaring question remains, what if the universe has stopped expanding? The possibility is as real as it gets, so let's just talk about the upcoming implications of the same. If you've ever been scared of the idea of the apocalypse, we've got bad news. A theoretical collapse of the universe has been in question for decades, but it wasn't until the recent revelations that we were forced to take it seriously. While it's too soon to call it quits and reject everything we know about the universe, we've still got to accept that this possibility has some real chances of coming true. This event is being dubbed the Big Crunch, where the universe would collapse in on itself. But why is this likely? Well, for starters, there's a limit to dark energy, and let's just say that it might have run out of time. In case dark energy starts to weaken or lose its grip on the universe, the consequences would be catastrophic. This is what scientists are afraid of. We don't know for sure if dark energy has any role in the expansion of the universe, but its weakening could have some serious repercussions. Now that we've reached a stalemate in terms of astronomical theories, a huge question mark looms over the fate of our universe. It is likely that the dark energy is weakening, which means that the galaxies would stop moving away from each other and instead move closer to one another. This domino effect will collapse the universe into a single superdense point, similar to how the Big Bang started everything. Of course, scientists are only speculating on the data revealed by the James Webb Telescope, but you get the gist of how big this event is. We're talking about the end of the universe as we know it, and that too by a huge margin. What's more, this conclusion would also bring a whole set of challenges and worries. Since it is only a matter of time, our universe could be ending in the next few seconds, or in a few billion years, depending on how the new astronomical data pans out. But you know what, let's just take it easy. We're not heading towards an apocalypse yet, but it could be that we've just been thrown back to square one. It's likely that the latest revelation could make us rethink the theories we've long taken for granted. Maybe the universe hasn't stopped expanding at all. The James Webb Telescope has made a discovery, and now it's up to us to theorize how to go about it. With so many astronomers on the case, it's certain that new discoveries and more data would be the end of it. What we do with the latest discovery is crucial, and even though the chances of a cosmic collapse are somewhat dire, there are also possibilities that this is the beginning of the next era in cosmology. We don't know for sure what to expect, but one thing is certain. This is just the beginning. There's no definitive answer yet, and the scientific community will continue to work on this groundbreaking discovery.